Evan Siegel. I received my PhD in 2000. I've been teaching math mostly at the college level for 35, 40 years, from remedial courses through graduate courses, abstract algebra, Galois theory. In addition, I've taught college courses and high school AP courses in Python, C++, C, Java, JavaScript, and Visual Basic for applications. In the late 80s and early 90s, I was assigned to run the remedial classes in two different departments. My biggest chore was producing exams. In my second year at this task, I was to produce exams for two different remedial classes, three exams, plus a final exam, plus answer sheets for each exam, and with two versions for each class each term. It was grueling and tedious work, and frankly, error prone. It occurred to me that this could be automated. After a few years of work, I used Visual Basic for applications to produce the two final exams with randomized questions presented in randomized order, complete with answer sheets. So here is a example of that. But before I talk about that, I just want to say the advantages of producing exams algorithmically are obvious. First of all, it takes as much time to produce 100 exams as it takes to make one. Second, it cuts down on the possibility of cheating. Third, it is practically infinitely developable. New problems can be added and old ones dropped for tweaked. So here is an example of some of my work. Okay, so this is the file with the VBA code in it. This is the Microsoft Word folder with a file with the code for the arithmetic. You can see that it's got VBA activated because it's got this little scroll here. And this is for algebra. Same here, the little scroll. Speaking of scroll down, you can see that there's no files with exams or answer sheets in them here. So you're going to see them appear in a minute. So let's go for the arithmetic classes first. So I just click Start. I want to have how many exams? Let's go for 2. And it'll take about 30 seconds, I think, for both exams to appear. There you go. Close this. Don't save. And as I said, here's the folder with the arithmetic test questions and the answers. Let's look at the questions first, I guess. Notice that there's 2 of them. The tests are number coded. So this is test number 1. And this is test number 2. We'll see why that's so useful in a minute. Here's the test. I think it's pretty indistinguishable from the original test. This is the usual first term remedial exams that we knew and love. These are the final exams. These are not, of course, all of the exams. I didn't code all the exams yet. And let's look at the answer sheet. Well, oh, and by the way, here's the, I already showed you that already. This is for the number 2. Let's look at the answer sheet. So these are the answers. And these are multiple choice and free choice. So that's about it. And of course, the other thing is that the answer sheets are number coded also. So this is the answer sheet that goes for the first exam. And then we have the answer sheet that goes for the second exam right over here, as you can see. Okay. The files for the um, algebra test, pretty much the same idea. It take a little bit longer because this test includes graphing problems, and graphs require my going to Excel to generate the graphs and copy them and paste them into the test. So let's just have a quick look at um, the folder that I created for the algebra test questions and answers. So here's that. And there's not a whole lot more for me to say. These are the questions. The graph will appear, yes, it does. And or another graph. Um, and these are the answers. Here you can see the answers generated by Excel. And that, my friends, is that. Second, it was difficult and perhaps impossible to develop more sophisticated tools to post mathematical formulae. LaTeX offered the ideal solution here. It has the scope and the reach and polish that VBA lacks. I chose Python to generate the LaTeX code. Here are the results of two projects I produced. Exam or homework assignment. And well, the code is rather long and involved, and this is only a part of it. But gets the job done. So let's get it started. This is using PyTech, Pike. It's called anyway. PyCharm, and it works like a charm once you get used to it. So here it goes. Okay, again, how many would I like to print? So I'm going to go for 2. And again, it's very fast. Then I'm going to reach for text work. Here it is. So, so what I've done in this first using PyCharm is I've run the code to generate the LaTeX. The LaTeX code is generated down here. So I'm going to copy that and paste it in okay. And the only annoying thing about this is that I have to delete these two first lines and the last line. And I can't think of a way of, I couldn't find a way of automating that. So that's kind of a nuisance, but on the whole, it's not a big deal, I don't think. So you just press the little button here, save, not save, it doesn't matter. And here are the two tests that I requested. You can see that the quality of the output is much cleaner. It's really good, crisp, sharp LaTeX. Um, these are the questions. Nice little graph here, generated in very little time. Sometimes generating graphs is a problem that can be very time consuming. These were very simple graphs, so it's not a big issue. All right. And that's the end of the questions. And here come the answers. This, I think, is really nifty. You have these little dots at the end of a interval indicate. And more answers. That one I missed. Oh no, this is a. This. I didn't put the sketch in there. Too bad. The size of the graphs are a little hard. Well, I have to work on anticipating the size of the graph so they'll fit in the display on the graph. This is the second test. The order of the questions are not randomized, by the way, in case you didn't notice. And the answer sheet. And again, it's really kind of cool. This is the endpoint of an open interval, the other endpoint of an open interval. Kind of nice. So this is the homework problem, and I'm going to give you now a midterm exam for